Swayam Prabha. Digital India. Educated India.
This lecture will focus mainly, as you see the little picture at the bottom. It's about how CD-ROM drive works. Okay, so we ponder over this question, like you have been using some CD-ROM or CD drives in the past. You might have. I'm not very sure nowadays. People don't use them so much, but I'm sure you might have listened to some music on CDs, maybe a few years in the past, maybe. Okay, so one has to think about what is there inside this drive and how the data is there stored on the surface of a CD, and how that data is read, what kind of system, mechatronic system is needed to do that job. Okay, so we'll start this with a very different kind of a approach. We'll not do some theoretical kind of a understanding first, and then see, okay, what is there. We'll actually open up the CD-ROM drive, and I'll show you the pictures of this as we go along, and start kind of discussing some of the interesting aspect that you see there. Okay, so now while thinking about CD-ROM drive, you need to think about these four elements that are there here. Okay, so you can see these are the four elements that we are discussing. Microcontroller, actuator, then you have actual CD system, and then you'll have a feedback, some kind of a feedback from the system. You may have these sensors. This is plant here, and then there are sensors here. Okay, so actuator, plant, sensors, and controller. Okay, these four elements will be indispensable for any of the mechatronic system. Okay, or you may have many subsystems that will be there as a part of a big mechatronic system. Okay, so either way, we need to look at all the subsystems be broken up into these components. Okay, and then there are other aspects of the design that will go along as we start opening up, that will come up. Okay, so maybe let us start with the discussion here on the thing to question. First is how do you think it works. So you might have maybe looked at, or some Google it and saying, okay, oh, this CD-ROM has some optical way the data is written on the surface, and there is some optical pickup which picks up the data from the surface. So let's get into the more details about it. So the goal here is to kind of develop the philosophy of design of mechatronic systems, not particularly this particular system, but how do you think in terms of design for such a system. Okay, so given problem, how do you kind of synthesize a solution, and then you'll see the need for this critical thinking in both the domains. Okay, mechanical domain and electronic domain together, to see, okay, how we come up with the requirements, how do we give the solution to the requirements of the application. And then other aspect is to kind of look at already existing elegant solutions to these problems which are already solved, and understand some of the design principles which are optimized principles in some way, that how do we make use of that in our case. Okay, and then finally learn about several aspects of the design which requires modification in mechanical domain to suit implementation in electronics. So this is integrated philosophy of thinking that we'll try to learn through. Okay, so let me get a pointer properly here. Okay, uh, mm, okay. So now let's move on with the problem at hand. Okay, think about what is a function of CD-ROM drive. As we have said already, okay, it has to store a huge amount of data. Okay, this data is stored in form of, say, some small bits and lands on the surface of CD. We don't worry about how this data is written. Okay, but it is written in some kind of a form, and when a user demands that, okay, I want to open some file, or I want to listen to some music that is there in the CD, I should be able to get it. Okay, so when the user demands that, I want to open this particular file, you have to kind of do something to go to that portion of the CD and pick up that data from there and give it to the user. That is a kind of a problem that we are looking at. So now let's look at the CD and how it looks under microscope. Okay, so let's do that now. Okay, so can you see that the CD has a surface which has this use of these different colors. Can you ponder over and see why these colors have to be seen here? Okay, think about this question, like, why do you see the surface of CD has this kind of a different colors coming up? Okay, so what is the physics of light that is going on there which gives you this different hues of the colors? Now under microscope, we'll come to that question when we discuss, or you may answer that in the discussions. Okay, so if you zoom in this small part of the surface, you'll find that there are so many dots that kind of a seen here. It's not very clear. You may not very clearly see anything in microscope, but as you zoom in further, you may see these kind of tracks that are there on the surface of CD. Okay, these tracks also are not so kind of a sharply visible, because their dimensions are like almost coming to the wavelength of the light. Okay, so light wavelength, for example, in the visible range, say for example this red light that will have is 630 nanometers kind of a range, and these tracks will be like 1.6 microns kind of a dimension, or 0.5 micron each track kind of a dimension. Then they will not be visible clearly. Okay, so to discern, you need the features to be much more size than the wavelength of the light. These are more size than the wavelength of light, but they are not much more than the wavelength of light. So that's why you can see them somewhat, but you cannot see them very clearly. Okay, so now the question. Okay, um, okay, so what can you think of a system to read this data? So I want you to kind of pause here for a while and think about. Okay, see what can you think to kind of read this data from the surface of an actual CD. So given that, okay, you have this data which is written in these forms of like small lands and bits, how do you kind of design a system which will read this data? So let's assume that, okay, if there is some kind of a read head which can read, we can shine a light on the surface of the CD, and the light falls on the surface and it gets reflected from the surface, bounce back, and if it is falling on land, it will kind of reflect like a white light, and then if it is falling in the pit, then it cannot reflect. Okay, so that's one simple kind of a way one can think about that. Okay, I'm shining a light, very focused, tightly focused light on the surface of a track, and then the track, if it has a it has that land or data written in 0 or 1 form, then if it is a land, it is light is getting reflected or not reflected from the surface will tell me whether the data is 0 or 1. Okay, that's a simple kind of a head that can be possible. Now the question is, you want to make sure that this head moves on the track all the time. How would you do that? These tracks, if you see, they are so close to each other. Okay, so if you see that they are so close to each other, as you can see here. Okay, so such a closeness of the tracks, how do you kind of maintain that your focus spot remains on the surface of the on the single track? Okay, and it continues to remain there as you start reading the data. They said a CD is spinning and spinning at some speed, and like this track is getting past so this CD is spinning here, and this track is passing under the head, and you need to make sure that head is moved only such that it is kind of continues to remain on that track. Okay. Oh, by the way, the data that is written here is in the form of a single spiral. Okay, so the spiral starts from the small end of the CD and continues in a way to the larger radius. So small radius it starts and continues to the larger radius. Okay, like that a single spiral is there. So you need to kind of make sure that okay the head is continuously moved on the surface in the radial direction with the precision of say something like can you guess what will be the precision? If this is say the track, between the track the distance is about 1.5 microns, the precision that is needed will be what? At least some hundreds of nanometers, or 100 or little less than 100 nanometers kind of a precision will be needed. Okay, so 10% also, if you say 10% of 1.6 micron is 160 nanometers kind of a precision that will be needed there. Okay, so we want to kind of create a system which can do this kind of a nanometric precision kind of a movement on the surface. How would we what thoughts come to your mind based on your knowledge so far you have done with some microcontroller programming and things like that? What kind of actuators can you think about for such a system to exist? Okay, so you give a good thought to these before kind of proceeding from here. Okay, so wherever these questions are I will not stop for the sake of memory of the lecture that we are recording here, but at every point of this where this you see this little icon here, okay, a person thinking, you need to be doing that job. Okay, and see what kind of things come to your mind when see, because it's very important that you raise these questions in your own mind to understand what is there, and it will open up really interesting kind of a dimension. Okay, um, because we start thinking in whatever, based on whatever knowledge that we have, and then we start putting things together at least on the paper for such a thing, and then we'll see when actually you open up and see some stuff, it will have some different understanding that will happening, and that is what is important, because that will kind of correct some of the ways you were thinking previously to what is the right direction to think. So that process is very important. I'm reiterating here, but please pause here. Don't go through unless you have thought about this question yourself. Okay. So the question I raised is not just this, but how do you kind of move the things on the surface of the CD? Okay, that question also you should think about. Now let us open up these are the questions that actually I wanted to you to think about and pause here. So maybe you can list down some of your ideas and on the paper and start thinking about them and things like that, and we'll proceed for actually seeing what is there inside. Okay, so we'll actually take a CD-ROM drive, open it up and start looking inside and observing. Our keen observation, as I said earlier also, is going to kind of teach us something. Okay, so let us start with the opening. Okay, so you have this CD-ROM drive. the brand new CD-ROM drive, and then you can locate, like, there are these 4 screws up here. Okay, these screws you remove, and then like, you'll be able to open this top thing up. And in addition, you can see, like, you can observe that there are a lot of mechanical interlocking that is provided, okay, to reduce the number of screws and things like that. Okay, as you start opening up, you will find somewhere you need to move some mechanical lock. I'll show some picture of some of the locks to just kind of, like, slide that lock, and like things will open up. Okay, so we'll proceed now. So this is what, once you open up the cover, this is what you will see inside. Okay, now so we need to kind of now slowly observe things carefully and start making sense. Okay, so this electronics, we may not be able to make much sense, because we cannot, like, we can just see the chips and, like, maybe take their data sheets. I mean, take their numbers and look at the data sheets, and, like, then we can make more sense of circuits. Okay, but mechanical things, certainly we will be able to do a lot of make a lot of sense of out of these mechanical components. Okay, so let's observe them. So there is this one of the locks that, you need to push this lock in the side in this direction, that, and then, like, it will open up from this, it will release this PCB, so that you can lift the PCB up. Okay, and then you'll find that there are these flat connectors that are used. Okay, see, there are a lot of things that you can observe. I've listed only a few of them. I mean, I'm leaving more for you to kind of explore and observe, and think about and ask questions. Okay, that's what we should then it will be much more healthier kind of a process, rather than I'm pointing all the time up to some kind of a things in the observations. So this is like some kind of a PCB which is doing the control and reading the data from the surface of the CD, storing it somewhere, and communicating it to your PC. Then you will find that these are kind of a flat cables that are used for connection. Okay, now one can think about why these kind of a flat cables are used. Okay, and not normal wires. So think about that. And then, like, you'll need to remove these cables to kind of get access, like better access to mechanical components. Okay, so that is done here. So there are a lot of, like, small aspects that will come. This tray of this is a tray that is holding the CD. Okay, that tray needs to be coming out. To come out, like, for that tray, there are some kind of interlocks that will be provided, or clips that could be provided, and then you need to push something, and then, like, this tray can be pulled out. Those kind of things you will need to do. See, it will be excellent if you can, like, get some of these kind of systems, like CD-ROM or hard disk drive, which is gone from your, like, neighborhood shop, which is repairing shop. Okay, repair shop may, like, some people may have this thing available. They may give you some throwaway price, or they may kind of just give you without any cost. Okay, free of cost, because anyway it is gone, not working kind of a drive. Then, like, you just want to kind of explore it, people may be able to give you or spare it for you. Okay, we usually do in the normal classes, like, in physical classes, we give you actually some of these kind of systems, and let you explore them. Okay, so that opens up a lot of different kind of thinking and paradigm in our mind. In fact, everything we can talk about, say for example, like, how do you see through for such a design of such a frame. Okay, that itself is a very interesting topic to kind of deal with. How do you kind of think for such a design, and, like, it can be manufactured? What is the way this can be manufactured? Okay, so what kind of a die system you can have, so that you can manufacture such kind of components? Okay, see, because these are to be done in a masses. Okay, so then, like, the price of such system comes down, because like, they are fabricated in bulk. Okay, so for bulk fabrication or mass fabrication, or mass manufacturing, you need to have systems or thought processes which are different than like one-off system or two-off system fabrications. Okay, so there are a lot of things that can be talked about. But right now our focus is only on the mechatronics part of it. Okay, we'll not get into too many details about manufacturing and materials and the gory details of even some small mechanical designs, such as like this kind of release clips and things like that. Okay, so our focus will just focus on the mechatronics aspect of things. So this is like one of the systems. When you open up, like you observe this kind of a rubber or like a belt driven wheel, and which is operating like some system here with the gears and things to get it, and then like there is this gear which will kind of get a tray out and tray in for the CD. Okay, the CD tray is, so you I don't know whether, like, if you have operated, you'll remember that. Okay, you push some button on the CD drive, and then the tray pops out actually. Okay, so the CD tray pops out. You put a CD there, and then like it is taken inside and it is set in some way. Okay, somewhere. Okay, so so this is a mechanism which does the tray operation kind of a mechanism. So why this typically the belt drive is used here is to prevent the damage in case the tray is blocked. Okay, if the tray is blocked and then you still start like driving the motor. See, this is a motor up here. There is a motor below this. So this small little wheel is driven by this motor. And if something is locked and this wheel is not rotating, then the motor still keeps on rotating, and the belt starts slipping. Okay, so this arrangement is useful. See, if imagine if instead of this belt drive, okay, with a flexible kind of a belt, if you use a simple gear mechanism here, then what will happen is like the something is get stuck, or you are holding the tray manually, and then motor is trying to push it. Okay, the motor is not moving. Okay, then what happens is, whenever motor is not moving, you are holding the motor shaft, and still power is given to the motor. Can you imagine what's going to happen? Okay, think about, like you are giving a power to the motor. Okay, but you are holding the motor shaft. Motor is not kind of allowed to rotate. Then like you are actually pushing in a good amount of current into the motor windings. They'll start heating up, and if the motor is not designed to like get that kind of a heat, I mean, it cannot sustain this heat for a long time. I mean, for short durations the motor can sustain such kind of a heating. The temperatures don't go so high, but if you keep on doing that for like longer duration, then like slowly the motor will start, like the motor coils will start giving the heating so much that the enamel or like the insulation on the coil burns, and you'll see that the motor may not function afterwards. Okay, so motor will get burnt. Okay, if you don't take care of this blocking kind of issue, that when the output is blocked, motor is still allowed to rotate, but with the belt will slip on the motor surface. Okay, motor shaft. So this mechanism gets you the tray out. So let's observe this mechanism a little more closely here. Okay, with this video demonstration up here. So let me see how we run this video. Okay, maybe I'll have to go back to the pointer mode. Yeah, so you can see here, like this is a mechanism that moves. So now like motor is removed from here. You can see that there is no motor here. The belt is removed, belt is lying up here, but like as this rotates, like there is some gear might also have been removed from the system. So no, this gear is still intact. So if this gear, you see this gear rotates, so this, when this gear rotates, like no, this will move, slide here, and that sliding will do some interesting thing here. If you see, this sliding is pushing this small, like no, black tray up, okay, and then there is something that happens, because this up and down motion that is needed is to kind of unload the CD from the CD spinner, spinning motor. Okay, so when it is if you see, when it is pushed on this side, the CD is loaded, and like, in some other way the CD will get in the other direction, the CD will get unloaded. Okay, so that is a system for that. Now let's observe some more details about where the crux of the problem. Okay, where exactly the CD is placed, and how the CD optical pickup assembly actually, like, reads from the surface of the CD. Okay, so if you see this, after removing the couple of PCBs from the surface, you'll have this clear view of the mechanism here. So what you observe here is these two rods here. You see this one rod and this other rod. Okay, and so this was the mechanism up here for CD tray to be popped out, and all the motors and the gears, like, they have been removed now. And this is a motor which will drive the CD. Okay, if you see a upside down view here, the CD is kept upside down. Okay, here on the other side of the motor. Okay, so we are looking from the back end, so to say. Okay, CD will be put from the back side to kind of read, and then this is a head which or optical pickup assembly which moves on these two rods here sidewise. So the CD, imagine the CD has this as a axis, center of this motor as axis of rotation, and then, like, the CD is rotating like this in a big CD is there to that will rotate on this axis, and then the head is moving radially inward and outward when the CD is rotating. Okay, that is a kind of a 2 degree of freedom motion that is required for reading XY kind of a position. I mean, XY place tracks, lands and pits on the CD tracks. Okay, so you need to have XY positioning system for that. So one axis of rotation is CD rotation axis, and then other degree of freedom is radial motion on the surface. So it's not like you have fixed CD and you move the head around it. No, it's a CD is rotating, and like you just move the head radially inward and outward. So you can have multiple ways of picking up the position data. I mean, picking up the data from the surface of CD. But I mean, this is the most. I mean, the way that is designed, like, the CD can be spun, and you can have the radial motion possible for the head. Now let us observe, like, little things, little more details. You can see that here there is some kind of a screw mechanism, and then there is some motor here. There's 4 terminals that you see for this. The other things that you may have here is think about now, like, these motors are for what purpose, and how things are going to work in this case. So let's move on to the next. There is other kind of a version of same CD drive, but this is not the same company. This is a different company. It has a different kind of a optical pickup head. You can see here. Now some of the components are removed. Okay, don't kind of take it as it is. You can see only these are magnets here, and the coils and other kind of stuff here from here is removed. Okay, I'll show you, like, more detail what is removed from here. And then observe that this is a motor here on which the CD will sit. So you have seen that CD has this small little hole in the center. Okay, that hole will match with this step up here, so that the CD is located, like, radially really well. So the center of the CD and center of this rotation of the motor is matched by using that kind of a small step there. And the CD sits on the surface, and then, like, the head looks this optical pickup head lens is facing now the surface of the CD. Okay. Now some of these observations. Okay, so now you need to again ponder over these things. Uh, let's go back one. Okay, what are the different components that you find there in the drive, and what are they for? Okay, think about that. You may observe some things which is more than what I am making you observe in couple of slides to come, or in the previous slides also. But you need to think about different kind of components, why they are there and why they are that way only. Okay, so that kind of a discussions or that kind of a thinking process will be very very useful for further incorporating those kind of concepts into your own kind of a design. Then what components in the CD can you see are responsible for achieving this kind of a very fine motion? uh, okay, so this is very important to kind of see that what you saw there had some kind of a screw and some motor kind of a drive. Can that give you really this kind of a fine positioning is what you need to ponder over. Okay, if not, then what else is there to move? Huh? Then why do you need these components for achieving fine positioning? Okay, so some things you'll see is for fine positioning, something is there, and then you need to think, okay, why these, how they are kind of helping us to do the job. Okay, so this slowly we'll start exploring these questions as we start doing more and more keen observations. Okay, so. So see, this is another kind of a mechanical interlock for the PCB, as to avoid number of screws that are put in the system. So you can see that this some small holes are provided, and some pins are coming out of those holes. Those plastic pins are kind of locating this PCB with respect to the motor, or those kind of locations with respect to this holder of the tray, so that they don't move from place, and they'll get when you assemble disassemble, they'll go in exactly same place. So these locations of various components is an important consideration, okay, from the mechanical design perspective. So we'll see this how do we locate things with respect to each other, so that they are in the right place when you assemble and disassemble later. We'll have a class, we'll have discussions in some of the future classes about that. Then you have this optical pickup system. So it's a gross motion for that system. You can see that this is now zoomed in view of that little screw that you are seeing. So this is a screw up here, and it has a motor on one end. This motor has these 4 terminals here. So see, normally we can identify based on these terminals here, what kind of motor it will be. Okay, so if you have more than 2 terminals, it's not going to be a servo motor. Okay, servo motor will typically have 2 terminals, plus and minus coming out, but this seems to have more number of terminals. So this is like a stepper motor here. Okay, another way, you will start moving the screw, and you'll observe that, okay, this moves in the steps. Okay, you can kind of feel that steps. Okay, that is another way to identify, okay, yeah, this is a stepper motor really. Then there are these 2 snugs, okay, which are moving on the screw. Why there are 2? Think about that. Okay, how are they helping? Why there are 2 things that are required here, and why not more than 2? Okay, or why not less than 2? Okay, why not only 1? Okay, then what is this spring for? So the spring is actually pushing this on this two stubs. Okay, so and if you carefully observe this area, so one stub will be touching this side, and other stub is touching this side of the screw. So you see that for a thread that is there on the screw thread that is there on the shaft, one side is touched by one stub and other side is touched by other stub. Here what you observe is some small little rubber bush here, and hole inside. So this goes on to something, and this on the rubber bush, this entire thing is resting. They are like that rubber bushes. You'll see four of them at four different points, or at four corners of this assembly, and they help in doing the shock absorption. Okay, so mechanical vibrations that are coming from the mechanical vibrations, or some shocks that are coming from ambient, they are prevented to go into the this high precision positioning system. And you can see this is a rod, which is guide rod for the head to move. So we move further here, and then now observe some more things. Okay, so if you see now, this is like a, how do you operate this screw moves, and this so now we are doing a reverse kind of a drive here. We are actually driving the stuff, and then the motor moves actually. Okay, so this is how typically you have this drive system working. And you see there is the other kind of a corner, this small little um, rubber bush, which is used for shock absorption purposes. Okay.